Okay, good morning. Thank you so much for coming out. I know it's the last day and this is the 9 a.m. slot, so I do appreciate, and this is also the room that I think is the furthest from the entrance. So I admire your perseverance for getting here and not just thinking better of it halfway along and just falling into the overflow room for a little bit of a sleep. So hopefully I'll keep this brief but entertaining. So thank you so much for coming along. My name's Sam Newman. I'm going to be talking to you today about confusion in the land of the serverless. I wrote a book a couple of years ago called Building Microservices. This presentation isn't about microservices specifically. It's more about some technology that's often talked about in the same breath as microservices, namely serverless computing. Since I was here last, a couple of years ago, I've now set up my own consultancy called Sam Newman Associates. My accountant made me put the "and associates" in because it sounds a bit more official, because it's just me and my wife that run it. But just there aren't really, at the moment at least, any associates. But I am available for consulting, training, wedding, bar mitzvahs, after dinner speaking, whatever you've got, I'm up for it. Setting up a company made 2017 a pretty big year for me. There was lots of things going on, lots of very important, interesting things that happened around the turn of the year that gave us all pause for thought. And I'm not really talking just about the political situation. I'm more talking about something significantly more important was happening around the beginning of the year. Pretty much the most important person in my world, and the most important person in my world is me. And I had the misfortune of turning 40, and so now I do feel old. My back hurts. My back hurts quite a lot this week after a couple of days of training earlier, and I'm starting to feel my age. I make noises now when I sit down in chairs. I make louder noises when I have to get out of those chairs. In fact, I think that getting out of a chair is pretty much the worst thing that happens to me in a given 24-hour period. So I still remember when the internet came on these things, and made the nice screeching sounds. I remember that little buzz excitement when I got my first 14.4K modem. I thought, oh, now I might be able to download pictures. I remember when most people's home pages were on GeoCities and consisted almost entirely of little animated GIFs of workmen doing this, with "this site is under construction." It's back when we thought that the animated GIF was the height of sophistication. I still insist on calling Facebook the Facebook because that's its name. I also don't use it because it scares me a little bit. And I have absolutely no idea what Snapchat is, other than my son sits every now and then and makes a gurning face and goes, and then takes a photograph. And so if I sound a bit like an old fuddy-duddy, it's because I kind of like the idea of being a bit of a grumpy old fuddy-duddy, because it's like you can settle into your middle and later 8 years, and I thought I might as well get a head start on that. But just to set the context of the rest of the talk, I'm not somebody who is unaware of recent trends. I've been using Amazon Web Services from the very beginning. I had the fortune, along with an old colleague of mine, Chris Reed, and James Lewis, to do the first ever public training courses for Amazon Web Services way back in 2009. And so I know of which I speak. But nonetheless, this whole new wave of serverless computing, when I started looking into it initially, left me feeling extremely confused about what on earth is going on. And I want to share some of that confusion with you, and actually some of the puzzles that still remain, despite having looked a lot into this technology recently. And the confusion, of course, does indeed start with this god-awful name. Now, I'm a fine one to talk about coming up with some sort of arbitrary buzzword, given that I'm the one person that's been making my living for the last 3 years out of the microservices trend. I just want to say that, at least based on the Gartner hype curve, my buzzword is winning at the moment, because we're much, much higher. And I think the goal is to be very high on this thing, but serverless is way down here, so that means they're losing. But at one point, I will now be talking about microservices in the same way we talked about MVC. That's a thing. I thought it was all MVVP or something. But anyway, now we're all talking about serverless, but it is quite confusing because the name is confusing, and it starts there, doesn't it? Serverless. I've got less servers, which doesn't really feel grammatically correct. And of course, the confusion starts here because there are machines here, obviously, aren't there? There are servers sitting there somewhere. So what do we actually mean by this? And people like get hung up on this idea, but there are computers there. So actually, you do need to understand about computers. It's just other people's computers. So from a privacy angle, that starts getting interesting. And so I started trying to dig around for some definitive definitions of what serverless meant. And one of the very first references that's sort of often cited in the context of serverless computing is this article. It's almost certainly probably not the first example of the use of the word serverless, but it's one of the more better known. And actually this description started helping put some shape to this when I went back and read it about a year ago. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think that much about them. To be fair, I've worked with an awful lot of developers that don't think very much about computers. That's partly what the whole DevOps movement was about. But anyway, I digress. Computing resources get used as services without having to manage around physical capacity or limits. So there is something there about this idea that we have an abstraction over computing resources. Okay. So this is 2012. Now it's quite interesting to note that often people use serverless as a shorthand for what are functions as a service. This is 2012. Lambda itself, which was the first sort of function as a service publicly available, wasn't launched until 2014. So we have to recognize straight away that the concept of serverless encapsulates more than just Lambda and cloud functions and all the other things. And the thing is, this has become very exciting for developers, though. They're running around going, oh, I've got this amazing platform that lets me do these wonderful things, and it's amazing, and I don't have to worry about this stuff anymore, and like I'm going to be really empowered, and I'm going to run a new media company, and it's going to be fantastic, and I'm going to pay cents on the dollar, and it's just a wonderful, wonderful land that I operate in. Meanwhile, all your operations people that are running these sorts of things are going, but what's going on? I've just got all these machines, and you're running around talking about serverless crap. And the reality is, this is the problem with serverless as a concept. Ultimately, it's entirely in the eye of the beholder, right? It's serverless is from the point of view of the user. Right now, of course, what we have are hosted cloud platforms that provide us with serverless-based technology, and we're relying on the nice people at Amazon and Google and Microsoft to handle that stuff for us. But serverless platforms are now coming into the enterprise. If you throw a rock right now, you'll hit someone creating an open source framework to deliver functions as a service on Cloud Foundry or Kubernetes, for example. And so we do need to recognize as well that serverless is primarily sort of a consumer-facing idea. And that's what we need to think about. It's serverless only from the point of view of the use of the user, of the use of the platform. So the definition from 2012 was interesting, this idea of an abstracted set of resources, but it's not a very crisp definition. And it didn't even account for what happens now in terms of functions, and so functions have shifted things on. So I looked a bit further afield for maybe a more up-to-date definition. And an old colleague of mine, Mike Roberts, did a long post over on Martin Fowler's site talking about microservices, or sort of serverless architectures, putting them in the context of microservices as well, trying to really dive into what makes serverless computing different to other things that we talked about before. And so Mike's taken an attempt to come up with a bit of a definition model for when something is or isn't serverless, which he's subsequently published. And he has 5 sort of criteria for a platform to be serverless. And it starts off with there are no management or server hosts or server processes. So we're not talking about a unit of deployment as being, I'm going to have 5 instances of something. I mean, the moment I start talking about an instances, I'm talking really in terms of hosts, or I'm talking in terms of processes. It's going to auto-scale up based on load. It's going to auto-scale up based on load. Costs are going to be based on precise usage. It's interesting that you can, of course, drive a truck through the phrase precise usage. I mean, some people will be charging per invocation, some per hour, might still be pretty precise. And performance is going to be based in terms other than host size or count. So you're not just going to say, I want 10 more. Yeah, there's some other characteristic you've got there. And there's also this idea of implicit high availability. that almost you don't have to worry about that. The platform is going to handle high availability for you. Now, Mike's article is really great, and I appreciate his attempt here at coming up with this definition, because it sort of helps us. It starts, at least it moves the conversation forward a little bit. And so, as I always do when I get characteristics like this, I start matching it to other things out there. And I start thinking of, what is the gold standard for me historically has been about different types of platforms like Heroku and things. Do they match these criteria? Now, there's some things that certainly do match Mike's criteria. I mean, we look at things like Lambda and cloud functions, like these function as a service type products. These are obviously serverless. These are what became popular around serverless time. But also things like Backend as a service products are also, of course, are serverless in that same context. Things like Google's Bigtable and Amazon Dynamo. These are database backends that will just scale seamlessly based on your usage. You're not having to provision an RDS instance like I would with Amazon. I just sort of throw data in and magic happens at the back end where lots of data pixies run around and move your packets around and it'll all be fine. Don't look behind the curtain. It's absolutely safe and nothing's going to go wrong. But of course I thought, okay, well, a big part of this serverless movement is about making things very empowered for the developer. The developer feels that they're able to get things done. It feels like a great, productive platform. And so I started thinking, but hang on a minute, I still consider Heroku to be the gold standard of publicly hosted platform as a service out there. It's still got, they nailed that abstraction really well. I think, anyone here actually used Heroku? It's quite a few people, right? It's so easy to get up and running. And the biggest complaint typically about Heroku is it gets expensive at certain volumes because it's basically just you're just paying a wrapper tax on top of Amazon Web Services on the top. But actually, based on Mike's definition of serverless, Heroku doesn't cut it because actually your scaling unit is your dynamos you're spinning up. Your unit of scaling is still hosts, and also you have to yourself turn off machines that aren't being used. So you don't have this idea of scaling based on precise usage. And so I started thinking, okay, are there other things out there that do match Mike's definition of serverless that don't actually feel like serverless platforms to us, to try and get a bit closer to that definition? When you get down to it, Salesforce actually matches the definition of a serverless computing platform. You can run arbitrary code on it. You don't scale in terms of resource counts or pods or anything else. Whether or not costs are based on precise usage or not, I think is up for grabs. But also things like content delivery networks fit in this realm. If the application you are delivering, for example, is a single-page app and maybe is a pure client-side single-page app, I could actually use something like Fastly as a serverless computing platform. I just deploy my application, I'm scaling it out over clients' machines. But we don't think of these as being serverless, which kind of implies to me that I think Mike's definition is good, but it's still not quite nailing the definition of what serverless is. I think it becomes useful actually to put the serverless solutions in the context of other types of platforms. You've probably been familiar with the various sort of infrastructure as a service type platforms. This is where that sort of cloud computing revolution began for many of us. The ability to automate cloud-based primitives around things like storage, compute, and network. So Amazon Web Services, Google, and Amazon and DigitalOcean, and I'll probably say Amazon again, because Amazon's the big beast that everyone's scared of. These ideas of low-level primitives that allow you to recreate effectively like racking up physical machines in a cloud-based environment. And more recently, we've been talking a bit more about things like container as a service. Things that sort of bridge the gap between sort of these lower-level, I've just got a machine, and high-level platforms as a service that are actually scaling containers. So you're thinking here of platforms like, arguably you could argue one way or another whether or not things like Service Fabric fits in this space, but certainly things like Mesos Marathon and Kubernetes fit in this space. And then you've got those higher abstraction platforms. These are platforms as a service. Now these platforms as a service give you that level of abstraction over the underlying computing resources, but typically place more constraints around you in terms of how you're able to develop your applications. And this is what the holy grail has been for many years for application developers. But aside from companies like Heroku, very, very few people have really nailed these abstractions well. I don't know if any of you used Google Cloud apps when they first got launched, Google Cloud Engine. It was a hot mess, I think, let's be fair to say, right? You got to run a version of Java, but it wasn't really just like Java, and you were sort of using an abstraction over JDO that was then using an abstraction over an abstraction over an abstraction over Bigtable, and you could run Python apps in it, but they weren't really like Python apps, and it was very hard to recreate the execution anywhere else. And over time, people refined these models, and we've got better. But if you look at function as a service and backend as a service, really they're sort of becoming building blocks to allow you to pull together your own solutions. But they sit very much in this space. Now, much higher level abstraction, they place constraints upon you in terms of what you're able to do, but they're sort of a nicer abstraction than the ones we've had in the past. I think also the cloud vendors have got a bit better about scaling up and scaling down. I used one of the early Rackspace platforms as a service for PHP applications, and it perennially suffered from this issue that it would scale up too slowly and scale down too quickly. And what that meant was that you couldn't really handle load that was in any way peaky or not. And so we'd actually have to artificially run load against the platform to keep the system running enough nodes for us. And I think over time, people understanding the usage of our platforms at the infrastructure as a service level and the container as a service level, I think the vendors have got a bit better about spinning these things up more quickly, but also our unit of deployment is much smaller. We think about a function, the cost of spinning up a function is quite low. And for me, really, this comes back to this idea that serverless computing, for me, really is nothing more, nothing less than actually platform as a service. It is. It's just a sort of a slightly higher abstraction platform as a service. And then, of course, you've got things like Kubernetes, which is wanting to be all things to all people at the moment, and is moving all around these areas saying, yes, we can do everything you want, but that's OK, because Cloud Foundry are doing the same thing. But all this stuff gets quite confusing, and you try explaining this to people, and you find yourself blurting it out in your sleep, and then getting confused at dinner parties and getting other things confused in with what other as-a services have we got out there. And you end up feeling like just a little bit of an ass. Because it does still get, we lose sight of this. We have these stack diagrams that I like using, like the one we saw before, and we sometimes lose sight of it. Lose sight of what's important, lose sight of why we should care. And actually, I think Kelsey Hightower here does kind of nail it. It's kind of interesting, I think he knows this quite well. When you have an idea, the last thing you want to worry about is setting up infrastructure. You just want to go. Which is why, I've used Heroku with so many teams in the past, because actually, although maybe long term you're going to need to do some more things and tweak some more knobs and dials and get more cost effectiveness over time, when you've got an idea, you just want to go. You don't worry about infrastructure. When you're trying to create a new product, when you're trying to get a new idea to market, the thing you're trying to prove is not, I can set up infrastructure, it's my idea is good. Serverless platforms are just giving us more ability to do this and broadening the scope of problems in which we can use these things. I like coming back to this definition from 2012. It still fits my mental models of what does make serverless different from things like Heroku and Kubernetes as is at the moment. It is that abstraction. It's that slightly higher level abstraction. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think that much about them. And that's where things get interesting, because almost in a way this goes full circle for me. Has anyone here heard this term before? Undifferentiated heavy lifting? So this was a term bandied about a lot when Amazon Web Services were launched, and it was being used to explain the mindset of why it exists in the first place. So Amazon had decided that the way they wanted to create software was by having these sort of autonomous teams that would own the whole life cycle of their software. They would do the product management, they would write the software, deploy it, support it in production, monitor it, and if appropriate, shut it down again. And the whole idea about this was autonomy and going fast. But what they realized was there was a large amount of effort involved in terms of handling the infrastructure for all of those sorts of things. So these two-pizza teams, as they were called, so two pizzas being no team should be so big that it can't be fed with two pizzas, which of course leads to a conversation about American-sized pizzas versus European-sized pizzas, and anyway, and then the Chicago pizzas. But anyway, we have small teams. It's quite a lot to ask for these teams to be okay. Well, I've now got to go and think about how I provision my kit. I've got to rack that up in data centers and plug the cables in, and that's literally earlier days what these two pizza teams at Amazon were having to do. And they said, well, actually, this is silly. So what we need to do is create core services that these teams can use to self-service, to give them that abstraction. In other words, this is just delivering on that promise. It's just what undifferentiated heavy lifting means to us now. Undifferentiated heavy lifting back then meant I don't want to have to buy a machine. Now it's like I don't have to worry about there being a machine. There should just be compute, storage, and network that is automatically assigned to me via my application stack on demand, and I can trust, this is important part of all of this, I can trust that they're going to look after it okay. So after going through this whole sort of journey myself and thinking it through, I started feeling a little bit better about what it was, and really this is another name for a type of a platform as a service. But there's still some other puzzles that remain for me in the land of the serverless computing. And one of those big ones comes up is around resiliency. So many years ago, I was involved doing some helping a client who was doing credit derivative trading. So I'm not going to explain what a credit derivative is, but if you want to read up about some of the socio-economic impacts of credit derivative trading and things like collateralized debt obligations, which I was also pricing, you can go and take a look at the film The Big Short about the global financial crisis. I'm not saying that I was entirely to blame for the global financial crisis. I was a little cog in the overall engine. I still remember when we had these things, and they said, so as I understand it, what we're doing is we're taking loads of bad debt, and we're putting it all in a big basket, and then we're saying it's good debt. And they go, yes, that's what we're doing. Explain it again. You put all bad things in a basket and it becomes good. And they go, yes. And then they did maths. And then I just assumed I was too dumb to understand what was going on. And that was almost certainly true. But also it turned out that no one else knew what was going on either. And it turns out you can't just put loads of bad debt in a basket and call it good. That's not actually how the world works. And then we had the global financial crisis and a good film and a good book that you should read about it. But anyway, I digress. The system we were working on, we were basically, these types of financial products were becoming more and more sort of heavily traded. And they'd gone from being quite an experimental kind of financial product to being something that we were trading at larger volume. And so one of the challenges was, how do you take these sort of financial products, often were hacked together, running in things like Excel and just arbitrary bits of C code, and actually start running them at scale. And so one of the things we did was we helped move this existing software onto a sort of a fancy kind of platform that no one talks about anymore. We've moved it onto a grid-based system. It's a product called Data Synapse. It actually wasn't bad at all at scaling and handling, sort of running a node of compute and allowing you to sort of transparently scale that up and down. Right? This is the precursor for many of the platforms that we use today. And so all of our little pricing agents sat in the middle of this big sort of cloud, if you will. It was a cloud. We had our own cloud. We had a private cloud, and it worked fine. This was 2005, 2006, that sort of time. And our sort of cloud of pricing agents ingested information from lots of different places. So one of the things it did was it pulled in information about risks, so the certain positions on risk of certain organizations and sort of companies. And so as your view of a risk of, say, a default, so the chance of a company going bust, as that changed, as that information came into us, we would go and look at all of those trades that were associated with that company and reprice them and see what the new position was like. And there was also other bits of market data that we were pulling in. And these were sort of external to the cloud. And obviously, we were pushing information into a database because that's what you do with your data. Then it's great. It's kind of interesting, this grid we picked. The reason we picked this particular product was because it had a very interesting capability, was that it allowed you to effectively execute Excel spreadsheets in a headless fashion on a grid. And you think, well, why on earth would you want to run effectively a farm of Excel processes? And that's because at this point, an awful lot of the trading that was being done was by traders that were running algorithms inside Excel spreadsheets on their desktops. And so when they were looking at a certain position, they wanted to understand their potential profit and loss and the potential risk of a trade. They'd enter in the product they wanted to sell, they'd hit a button, and out would come a number. And if they didn't like that number, because it didn't mean they were going to get a bonus, they would go and change the spreadsheet and then hit OK until the number came out the way they wanted it to. Now, understandably, when you spend a lot of time trying to analyze the risk of your financial positions as a large financial bank, the idea that your traders can just circumvent all this stuff by fiddling with things until they get the numbers they want didn't fill people with glee, and so there was an effort to centralize all these things. And so the idea was we're just going to lift and shift all these Excel spreadsheets effectively and run them in this wonderful, wonderful grid. And so this was going on, and it was going okay, but we were constrained at this point by how many machines that we had available to us. We really wanted to see how fast we could price these things. So we were doing what was called intraday pricing, which meant that rather than at the end of the trading day, we just looked at what our positions were. As new information flowed in, we were trying to dynamically reprice, and the idea being that we'd give information to our traders as quickly as possible and hopefully faster than the competition, and they would be able to make more money. We actually succeeded in doing that, but it turned out our models were really bad compared to the rest of the City of London. So the faster we priced, the more money they lost. So, anyway. So one of the things we did was we wanted more machines, and then one of our friends in the ops team said, well, hang on a minute. We've got a load of machines just sitting idle. So like a lot of financial organizations, this particular bank had a DR center, which was like a trading floor that was ready to be used in case we had to evacuate the building in London. So, obviously this was still, although things had calmed down a bit, the City of London still had a lot of procedures in place because of terrorist attacks and things. And so if that happened, you wanted to be able to evacuate, get to another building, and then carry out your trading without losing too much of the day. Although I do remember the only evacuation I was involved in was when someone's toast got stuck in a toaster, and it caused a fire alarm to go off, and we had to evacuate the entire building. So this whole office was sitting there idle. The machines were switched on and were running, because that was part of the sort of BCP planning. And so these idle machines were just doing nothing, and we were like, oh. And so our friend in the ops team said, look, you can run the grid agents on these machines because they actually can run inside a screensaver. And so when the screensaver pops on, if the screensaver's been operating for, say, 30 seconds or a minute, it then becomes available in the grid. And so we thought, fantastic. So we rolled out this new screensaver to these sort of, few hundred machines that were sitting idle, and our grid expanded. Like at lunchtime, it was awesome, especially because then we also got a lot of the machines that were running actually in the main office as well. So we drastically increased the size of our grid, and everything starts looking great. And then some weird things start happening. We're all very confused. I mean, it's just like everything else was falling over. And of course, what we had done is we'd massively scaled up the compute capacity of our grid and overwhelmed every single other service. And they'd all wiped it out, and that was not good. And this is actually a problem with our serverless platforms as well. This was a form of platform as a service, maybe not serverless, but when you have these things that scale, and scale transparently, and scale in such a way that you can't really control how they scale, you have the danger of overwhelming things. We are used to using things like database connection pools, right? Database connection pools work really well as a method of throttling calls. I've got some calls coming into my service, my application, and to go to the database, I have to go to the connection pool, get a thread, and then go and make a call. And we limit the number of threads inside that connection pool primarily to manage and throttle the load on our databases and things like that so we don't overwhelm them. And it's a throttling mechanism, it's a safety mechanism. And if you can't get access to the database because of that connection pool, because you can't get a thread, your request will time out and we shed load, again, protecting our systems. So it's a way of not only sort of stopping the database from being overwhelmed, but also stopping our applications from also being overwhelmed just by having these blocked pending connections. But of course, with a serverless platform, we don't have that throttling ability because our functions are not permanent. They're ephemeral. They're there per request in general, which means we don't have the luxury of a connection pool which manages multiple connections and has a sense of state to an extent, so it can see what's been happening and can handle things like timeouts over a period of time. And so as you know, you're adding your more functions, you're spinning them up on Cloud Functions or Lambda or whatever else. As your load increases, the underlying function platform is going to spin up more nodes. Spinning up more nodes, in turn, is going to have more requests coming in. Those requests coming in actually just result, of course, in the same problem because you've lost your ability to throttle. You cannot actually throttle the number of concurrent invocations for Amazon Lambda, for example, except by specifying a global limit at the account. You can kind of do this-ish at the API gateway, but even then, you can't do that entirely safely because often these functions, even if they're not running, will hang around for a little bit and will keep connections open. Now, of course, the answer is, well, don't use a traditional database. You need to use a backend as a service. Because then, of course, as the load comes in and you scale up, the underlying backend as a service, service platforms can handle that and just scale out automatically for you. It's interesting, actually. I don't know if any of you saw a talk on Wednesday from Stephen Faulkner, who was talking about his experiences at Bustle. And this is exactly what happened at Bustle when they started making heavy use of Amazon Lambda. They spun up all these Lambda jobs, and they completely wiped out their Redis instances. And they found that what was happening was that the functions, although they were actually leaving connections lying around, and that Redis was tapping out 10,000 connections per node. And they didn't have 10,000 requests coming in. It's just the nature of how the Lambda stuff works, that connections are being left lying around. And they had to jump through a lot of hoops to allow them to still use their own Redis instances to be able to handle that load, and the fact that you don't really have that natural throttling point. And this does ask me, so yeah, sure, you can go and say, yeah, just use Bigtable or go use Dynamo and it'll be fantastic, but that's not the world most of us live in. You know, Bustle are cited as being a massive 100% serverless shop, but they're not, right? Their backend database is actually shifting over to Redis, for example. That's not a serverless backend platform. Most of us, when we want to adopt a serverless architecture, we don't get the luxury of just going and rebuilding our application over here. What we're looking to do is take part of our stack and just rewrite that as serverless. And yet, already I've got the confusion here about how we handle resiliency in that mode. There's other types of resiliency we have to think about as well. I mean, many of us will be using things like circuit breakers in the context of, say, synchronous calls between services. Circuit breakers are quite a simple idea. When you're calling a downstream service, if that thing becomes unhealthy, you sort of open the circuit breaker, you go to failing fast rather than failing slow, which allows you to shed load, programmatically degrade functionality, give your downstream service time to recover, and sort of avoid resource contention. So load comes in, it gets again like a throttling mechanism effective. That's what the circuit breaker is almost doing here. It can act as a throttle. The downstream service has a bit of a wobble. We pop the circuit breaker open, and we say, I can't handle this right now. Come back again later. And we shed the load, and hopefully the world moves on. The issue, of course, here is that even more so than say, connection pools, these kind of circuit breakers rely on maintaining per-client state across requests. I need to be able to see over time, can this thing talk to this thing? Because often you have sort of local partitions and things. You actually need a per-client state. It's not enough to say, is the risk server down, and have some global concept of it being unhealthy, because actually clients will see different things based on just the networks they're routing over. And so the circuit breaker works by each client maintains that state over a period of time to assess the health of the downstream service and severs that connection. Now, of course, we don't have that capability here in the service platform either. And again, with hybrid applications, we're often talking about fronting our applications with functions on the front end and maybe with stateful services on the back end. That does start getting me wonder if what we're going to start seeing are sort of throttling and load shedding middleware for these sorts of worlds. Is this going to be another appliance that we stick in the network path, another form of glue? Or are we just going to have to start having kind of other funnels and things between our upstream functions and our downstream services and more traditional data stores? Of course, I also have to catch myself every now and then and realize, I'm talking about a lot of, this large scale, how you scale up these large systems. And actually, for many of us, scale isn't really that much of an issue, really. I mean, we like to say it is, and it's always fun going and seeing a talk by somebody who works at Facebook, but you don't work at Facebook. Well, you might do, but you probably don't. And I bet you do. You should probably call it Facebook rather than the Facebook. Anyway, I'm getting grumpy. So, actually, a lot of us don't have these scaling issues, and I think, but one of the things that the idea of serverless is predicated on is the ability to scale up. And so, we want a serverless platform to allow us to scale up a lot, but then for hybrid applications, which tend to be more mature, which are more likely to have large load, we're going to have these hybrid type problems, and it's like, I just don't know. And I thought I was being grumpy, and I went round, I spoke to Mike about it, Mike Roberts about it. He's spent a couple of years now focusing in this area, and it's like, is this a problem? Is this something we've got to think about? And he goes, yeah. And Steve Faulkner said, yeah, this is a problem. And it's like, we don't have solutions for this stuff right now, which is kind of interesting. So for those of you who are interested in sort of more of a hybrid solution, mixing an existing application stack with a serverless solution, just be aware of some of these interesting gotchas. Another puzzling area that's often cited in the context of serverless is around security. Especially when we start thinking about, how these things are going to operate. I mean, it's not a secret that actually, under the hood, for example, Lambda's running on Docker. And we're aware that with something like Docker or other container engines, that although they provide a level of isolation, they don't provide firm isolation between things. And so what that means is if you've got untrusted code running alongside your code on the same container engine, you have to be concerned about something in that container potentially breaching the container engine itself and gaining access to things it shouldn't. And so, it's this mantra I've had for many years, which is friends don't let friends run untrusted code in containers. If you want to run somebody else's arbitrary code on the same machine as yours, you're much better off using a virtual machine. And actually, that's what most cloud platforms do. When you spin up, say, an EC2 instance, your machine is a virtual machine sitting on top of a physical machine, and there are other people's stuff running around you on that same machine. But we sort of trust virtual machine isolation more than we do container-based isolation. And yet, when we're launching our functions, we have no real ability to know who else is running on that machine with us. So my function's running here, some other person's function is running there, and we start getting worried, what if they can reach out and see what's going on? Can they look at the machine I'm operating on and sniff out what's running? And there have actually been people that have done this in Lambda, for example, and shown that you can see what else is running on that same machine. Now, of course, the great argument here, and one of the reasons why from a security standpoint, function as a service specifically is actually quite a nice boon from a security point of view, is that if your function isn't running, it's not there, right? And so I can't look at your running process because unless it's taking a request, it's not there. And likelihood that gets shut down, and when another request comes in, you'll be on a different machine. So it's quite hard to go after your particular container if I'm actually targeting you specifically because it's quite ephemeral. And of course, that's the nice idea. And we're running in a sandbox. It's not just a container, there's another sandbox around it. But here's the thing, actually. This idea that if your function isn't running, it's not there, isn't actually entirely true. Especially for, say, JVM-based processes, at Lambda will keep some pre-warmed, and they won't shut them down straight away either because they know the spin-up time of the JVM is large. So containers will, your functions may actually be running for a period of time when you're not actually using them to give you the kind of performance and scale up sort of capacity you want. So that's still a little bit of a questionable thing. I do wonder, I think these sandboxes are probably the best answer to this because they do have the ability to build additional protections around those sandboxes. So I think in general, from a security standpoint, they're a good thing, but there still are a couple of little questions I have around it. The other question, the puzzle and the concern I have is around lock-in. It's really getting stuck into this sort of space. Because look, there's this great lie that's been spread for many, many years, is that that cloud is somehow utility, right? This is giant heaping amounts of horse poo. Absolute lie, right? What is utility? Utility is when I can go into a web page and say, I'm with this electricity provider, I want to be with this one. Nothing changes in my house. I just get a bill from somebody else. What happens now, I don't have to go and change my appliances because they're running the wrong frequency. This idea that we can just create these just lovely abstract patterns and move, like the closest thing I think we've got to utility really in say the cloud computing space is maybe at storage level, If I just want to move my files over, but even then that's work, right? So we do have this idea that we're just going to have transparency across cloud. It hasn't really delivered because actually it's a hard problem. It's a legitimately hard problem. I actually think abstraction platforms that are coming out, things like Service Fabric, things like Kubernetes and Cloud Foundry, are starting at the platform as a service level to give us utility at the point of an application developer. But the whole stacks, not so much. And especially around things like the FAS and BAS options, these are non-portable solutions on the most part. So is that a worry? Now, I don't like talking really about migration, about lock-in costs. I like the lock-in concerns. I really like talking about migration costs instead. That's a better way of thinking about this. It's actually all about opportunity cost. So if you're going to use any kind of sort of cloud-based product or primitive, you're just applying a little bit of conscious thought about, okay, if I decided to move, how much pain would it be for me to move this thing? And is that a concern that I've got? Is it a big enough cost that I'm worried about it and therefore might not use that feature or might look to create an abstraction on that feature? Because ultimately, not all things are equal, right? Now, the cost of migration of something like blob storage, or binary object storage, it's fairly low in the grand scheme of things, right? I can just export my data, import it, and like Amazon and people let me ship physical devices around, and they're fairly like for like. I mean, there were some interesting gotchas around the Azure blob storage, obviously, but they're pretty much like for like. Compute, it's there, I mean, once you've provisioned the machine, then you've got a machine. Actually, that's pretty similar. That's quite the same. Networking gets interesting. The load balancers, again, yeah, I can spin up an ELB or something on Amazon, but actually I could probably recreate that quite easy. So the cost it's a little bit more work. It's not too bad. But then, running a pure function as a service, if I've got a solution using Lambda right now, I'm using Lambda. There aren't yet sort of other portable ways of running those functions elsewhere, although that is starting to happen with IoT in the Amazon space, like it is with Microsoft. Even harder, of course, are these backends as a service. These are much, much more sophisticated products. And they don't have, on the whole, the same semantics as other types of solutions. So the migration cost is increased. And so when you're thinking about what services you're going to use, if you're going to buy into these platforms, have a little bit of a think about those migration costs and think, is this a worry to me? Ultimately, what you're trading off is this idea of, I either pay now or I pay later, or maybe pay later. That's the key thing. Right? So if I don't want to use this service that is provided out of the box from a vendor I'm already using, and instead I decide to do it myself so that I get portability, I am definitely paying a cost now in the hope that over the long term it will save me some money. On the other hand, if you never have to move, then you won't have to pay the money. So if you've paid the money now, you've wasted that money. And so it is a really interesting trade-off that you have to make. I think on the whole, I'm not so worried about things like function as a service. I'm a bit more worried about the backend as a service stuff because often we rely so heavily on those sorts of things. You just got to decide for yourself what it is you do. And it might not be all or nothing. You might actually explicitly say, okay, we're not going to use these things because actually they're quite hard to recreate. So certainly some of my clients, for example, have stayed clear of DynamoDB on Amazon for some things and would rather use RDS instances, which are the relational database service, because it's easier for them to port and also easier for them to run locally for test environments. Another thing that comes up is, should I mix vendors? Is this do I have a mix of cloud vendors so that I'm hedging my risk in case one jacks the prices up? And in serverless, this comes up a lot as well because, again, there's this idea that the serverless platforms aren't really comparable in terms of you can't just switch from one to the other at the moment. And here I'm a bit more like, I wouldn't for a given solution. You have all kinds of problems when you start mixing vendors in the same sort of application that you're creating. I mean, let's just talk about networks, shall we? Right, because you've got to route from your cloud center to provider over the public internet into somebody else's cloud provider system that might be running in a different part of the world, and that's going to get slow. Now, as a corporation, if you're a large enterprise organization, I think it's completely appropriate for you to say, we are mostly using Amazon Web Services, we're mostly using Azure. But I think for a larger corporation, it would definitely make sense for you to have expertise in other cloud platforms. But maybe that's at a product level, not at not on a particular application level. And we also do have to recognize that actually lock-in, being stuck inside a walled garden, can actually sometimes be really nice. Like, if we get awesome stuff, it's like, well, actually, I kind of don't mind this so much now. It's like, I'm a great user of Apple products. Because I know that Apple products are lovely. They're a walled garden, but they're a lovely walled garden. There's a nice dappling pool with a water feature, and someone brings you cocktails every now and then, and there's like a little live band playing in the area, and it's always sunny. It's always very sunny. It's very smug, but it's very sunny. I've been stuck in other walled gardens where the walls are they're there, but they're less like walls, more like a prison cell. It's like you're in a yard, outside some supermax prison, and every now and then the vendor comes around and beats you. And so, it just pays, you pays your money, you take your choice, and sometimes these places are quite nice to be. So sort of bringing all this stuff together, I'm still a little bit confused. And there are some things I feel a bit better about. And the term serverless, I've kind of got over it a little bit, because ultimately this is what we do. We come up with terms that sort of have meaning at some point in time, and then we overload them, and then they become completely and utterly meaningless. We think about agile, and agile means everything to everybody now. It's interesting to note that, say, with agile, I think it keeps it closer to the original core message, because it had early on a fairly good statement about what agile is and what agile should be, which means that manifesto kept us honest for a bit longer. DevOps, oh boy, has that ever been devalued. I'm a DevOps. What does that mean? I'm a DevOps consultant. I'll have 15 DevOps, please. Can I have 3 agiles and 15 DevOpses? That's not what DevOps is. DevOps isn't about tooling. DevOps is primarily about culture, actually, but doesn't stop vendors selling us stuff. Of course, the most recent buzzword of choice, microservices, which obviously are completely sane and rational, and you should definitely buy my book. And we've done it again with serverless. We've taken a term that had some meaning in some context, and we've rapidly overloaded it. And really, when you look at it, it's just a different type of a platform as a service. And then we also get into this silly group-thinky stuff that happens. Like, we're about serverless. I can't use that. That's not serverless, right? It's all about serverlesses all the time. And it's like, well, no, just, kind of use what works. If you're interested in this stuff, absolutely try it out. Caveats around where you use some of these features. Caveats around how deeply you embed your sort of mission-critical solutions on things that, at the moment at least, have a lower degree of portability than some of the other cloud products and cloud primitives that are out there. But ultimately, we are living in a world where, there are not going to be a smaller number of servers and a smaller number of computers out there. And yet, the number of machines out there is scaling significantly faster than the number of developers and operations people able to work with them. And so we need things that allow us to harness the power of these machines in more and more efficient ways. And serverless is just the next step in that. It'll be interesting to see if we start seeing other products, and I think a richer ecosystem around serverless. I'm especially interested around the resiliency side of things, especially around hybrid applications, because I think for most of us, we are in a situation where we have a system running today, and we would like to take advantage of these serverless technologies in a safe fashion. And so I'm hoping to see more great case studies like the one we saw from Bustle on Wednesday sharing these experiences. And so I'm a little less confused than when I started this journey, 2 or 3 years ago. I'm definitely older and definitely more grumpy. But hopefully, at least, I've shared some of that grumpiness with you to an extent and given you some things to think about. So thank you very much for your time. We have plenty of time for questions. If anyone's got any questions out there, I will try and see you with the lights. Okay. I can't see any questions, but that means that... Oh, question over here.
Hi, Sam.
Hello.
You haven't mentioned the fact about the sort of having to do with or how you deal with state in serverless stuff, and how is changes you sort of kind of seeing the world more in certainly with functions as a service, more event-driven style?
The question was, I didn't talk about statelessness or the event-driven nature of some of these things. Statelessness and statefulness is directly handled by the backend as a service. And so the reason I brought that up is I think often what people talk about with serverless is just functions, and it's definitely not just functions. The term serverless was around for 2 years before Lambda existed, and was being talked about in terms of things like the backend as a service, and they often get missed, so I think it's worth highlighting. Yeah, so things like Google's Bigtable, DynamoDB, no one uses SimpleDB anymore, and those sorts of serverless platforms that have serverless data storage platforms that have the same kind of semantics. The event-driven nature is interesting because, of course, that's where the Lambda stuff initially started, and I think that's actually quite a nice sweet spot for functions getting executed based on events arriving. Although it's quite interesting to note that, especially for functions on Lambda, what really exploded the growth of the use of the Lambda functions was the API gateway supporting it. And so I think when you just had event-driven functions, which are really, really useful, and I think Stephen put it really well on Wednesday, that's a great way of managing integration between a lot of these cloud primitives that don't always talk to each other. So now I can, based on something being put in a bucket in S3, fire a function that puts something into, say, Kinesis as an example, and functions work really well there. But for many people, the lack of that ability to trigger one from a synchronous call was holding it back, and so that sort of opened up, I think, the field for a lot of people. Personally, I'm a big fan of event-driven architectures, and I think functions in that space can work quite well. Then, of course, you're offloading your resiliency concerns to whatever brokerage software you're using to ship your stuff around. Again, same concerns come back, which is that's great if you're using SQS or SNS or Kinesis, but even they have scaling issues, and you're relying on a part. If you're putting it onto your own broker, you're still going to be able to scale that transparently. So in a way, it's a similar problem, I guess, to offloading, hybridizing with your own data store or the back end. There's some really interesting patterns. I would urge you to take a look at Mike Roberts' article on serverless architectures at Martin Fowler's website. He goes into some of this in more detail than I had time to today. Any other questions? I can't quite see where you are. You're at the back. Right, this is going to be fun. You'd have to yell.
I'll try. Can you hear this?
Yep.
Being a microservice component, are there use cases, projects where you see microservices are not a good fit?
So being a microservices proponent, are there situations, projects where I don't think microservices are a good fit? Yes. I think if you're starting out with a brand new product, like you're a startup or you're a company creating a brand new class of product, I think microservices can be problematic because you can't it's hard to get a firm enough understanding of your domain to identify stable service boundaries. And that means that you will get those boundaries wrong, and the cost of change between service boundaries is quite expensive. I'd also say that early on, what you're trying to prove is that this business idea works, not that you can build a distributed system. And so I think for early stage startups, for greenfield projects inside organizations, I'm much more likely to propose a more, say, modular monolith. So where you think, I think these things might be separate services, great. We'll make them separate modules in the same monolith for now, and keep the schema separate by all means, and let's see how we go. I did an article, if you search for microservices for Greenfield, I go into more detail on that idea. The other area where it comes out quite a bit, a few of my clients at the moment are doing customer installed software. When you adopt a microservice architecture, you're effectively pushing complexity into the deployment and operations arena. And normally the way you mitigate that is introducing new tools, technologies, deployment platforms to manage that complexity that you've created. And you can hide that and manage that yourself. But when you're having your customer install systems on your behalf, like I give you this, you install it, that complexity in the deployment arena that you're pushing out is now being borne by your customer. And they don't have access to the same sorts of, they just want to install an MSI. And so again, in those environments, I wouldn't suggest a microservice architecture. One of my clients, they want to do both. And so we're talking effectively about, we're thinking of every service as a component that almost as a post-processing step, you wrap it either as a service or you bundle it together as a monolith. That's a much more complex path to production, though. So those are the two good examples where I wouldn't be using a microservice architecture. And by extrapolation, maybe not a serverless architecture either. Certainly one of the challenges around functions is that you can get quite fine-grained into your interaction. So if you're not keeping those code bases very, very small, all the same things around coupled services can come up. Although I think in general, people are quite good at keeping their functions small because it's sort of everything. It's almost like the community feel around those is to keep the scope of those things really, really tiny. So hopefully that helps. I've probably got time for another question. You'll have to yell if I can't see you. All right, well, thank you so much for your time. As always, I will be available to answer a couple of questions afterwards, although I do need to get to the airport. You can find details about me up here if you're interested in hiring me or just asking me questions on Twitter. I'll answer any and all questions on cricket, rugby league, board games, and microservices and serverless computing. But thank you very much for your time.